All right, so what we want to do here is just figure out a couple different ways to calculate the marginal rate of substitution. Remember, the marginal rate of substitution is a measure that asks the consumer, if you lose a unit of X, how much Y would I need to give you in order to maintain utility? So what we're trying to do here is figure out the extent to which a consumer is willing to substitute a unit of X for Y at some bundle of the two goods. Okay, so the marginal rate of substitution can be calculated in a couple different ways. I think moving forward, what we want to do is think about it as the ratio of the marginal utility of X to the marginal utility of Y, which of course is going to be the derivative of the utility function with respect to X against the derivative of the utility function with respect to Y. And in this particular case, what that gives you is negative 3/2 Y over X, Y per X. So it's this term right here that we can substitute Y and X, different bundles of Y and X in there, and figure out how the consumer would react at those various measures, at those various bundles. So if we find a consumer with lots of X, right, so X is large and Y is small, and that gets them to a particular utility level, the marginal rate of substitution is going to be fairly cheap to perform, or because it's a negative number, it's going to be close to zero. On the other hand, if we see a consumer having a lot of Y and not much X, and it gets them to the same utility level as that first bundle I just described, it's going to be really expensive for us to compensate that consumer for a loss of X. Or the marginal rate of substitution is going to be really close to, or is going to be closer to negative infinity. It's going to be a smaller number. So if we think about this graphically, what this means is that as I find a consumer on a particular indifference curve that corresponds to utility level, the marginal rate of substitution when they have a lot of X and not much Y, right, and I can calculate that by taking the slope of the tangent line to that indifference curve, this number is pretty close to zero. Here, when they've got roughly equal amounts of the two goods, right, the MRS is going to move towards -1. It'll start to increase as they move up their indifference curve, and that's pretty obvious because the slopes of the tangent lines are increasing. And then finally, if I get here where it'll be really painful to give up X, which is highly scarce at this third point, it's going to be really expensive to compensate the consumer for their loss because they're having to give up a scarce good that has really, really high marginal utility value, and the marginal rate of substitution is going to be closer to negative infinity there.